Alright everyone, welcome back to the day 23 of our daily leetcode challenge, and today we have got count servers that communicate. So in this question what they've given us is a grid, and in each grid wherever there is a 1, that indicates that a server is present. So imagine this entire diagram that they have provided as a part of a matrix, and wherever there is a 1, that would indicate a server is present at that location. So what this means is this entire diagram is basically a matrix of ones and zeros. So it looks something like this. Wherever we have a server, there's a 1 there, and where we don't have a server, there's a 0 there. So this entire diagram that they have provided us is nothing but a matrix of m cross n. Now what they want us to do is they want us to find servers that have at least one server to communicate with. You can have more than one servers to communicate with as well, but we just need to find how many servers in the matrix exist such that they have at least one server to talk to. Now these servers can either be in that row or in that column. So if you take a look at this example 2 right here, you see the server at 0 comma the server as at this index 0th row 0th column has no server to communicate at the present row, but it has got one server to communicate with at the column. There could be even further servers located here, but the count doesn't matter. What we need to know is if there is at least one server to which it can talk to either in its row or in its column. That's what we need to find out. So in this first example we see that alright, this server right here has got no servers on its current row, but it has got one server in its current column to talk to. So this server checks out the condition that it has got at least one server to talk to. So far we have found one server. Now we come to this server right here. This server has got one server in its row to talk to and one server in its column to talk to. It has got two servers to talk to, but the count doesn't matter. If it has got at least one server to talk to, it's fine. So we add one more. Now we come to this server right here at this index. We see that it has got no server to talk to in its column, but it has got one server right here to talk to in its particular row. So again we add one. So the final answer becomes 3. Now let's take the example of this case, example 1. We see that the server at index 0 comma 0, this row and column has no server to talk to in its row and no server to talk to in its column. Same goes for this server as well. It has got no server to talk to in its row and no server to talk to in its column. That's why for in this case the answer is 0. Now let's take a look at the last example that they've given us. Let's see this server right here. This server right here has one server to talk to in this row and 0 servers to talk to in this particular column. So we got this server checks out, so we have 1 so far. In this case it has got no server to talk to in its row, in its column. It has got one server right here in its row to talk to, so we add one more to our answer. In this case it has got no servers to talk to in this particular row, but in its column it has got one server to talk to, so this server checks out, so +1. Same goes for this server as well. It has got no server to talk to in its row, but has got one server right here to talk to in its column, so we add +1. So far 4. And for this server there's not a single server in its row nor a single server in its column, so this server is left alone. So in that case we don't care about the server. This has got no one to talk to. So far our answer becomes 1 plus 1, 1 plus 1, which is 4. So this is what they want us to do. Now this might appear as a graph problem, because this is actually a graph problem. We can use BFS, DFS, do all that, because what we are doing is we are traversing in all those 4 directions to check if a particular server right here has got some server to talk to or not. All 4 directions we are traversing, right? To check if a particular server has got at any one server in either side, in any other side has got one server to talk to. This is what we are doing. But I propose another solution. We can use a graph for this solution as well. Let's see how we can solve this using a graph. So what I need you to imagine is, like, instead of doing all these iterations being all 4 sides, what we can do is we can maintain a count. And what I mean by that is, let's see. I'm going to explain you how we can use graph to solve this problem right here. So far we have understood that this is nothing but a matrix. Wherever we have a server, that's 1, and wherever we don't have a server, that's 0. So what we can do is we can create a hash map. 2 hash map will create. One hash map for all the rows that we have, and one hash map for all the columns that we have. What I mean by that is, let's take this bigger example. This will help you understand all the rest example as well. We have how many rows? We have 0, 1, 2, 3. So in total 4 rows right here and 4 columns right here. What we'll do is we'll create two hash maps, one for row hash maps, meaning I'll have a hash map h1, let's say, and for that hash map the keys will be the rows that we have: 0th row, first row, second row, and third row. These will be our keys, and initially all the values for these keys will be set to 0. All these values are set to 0. This is our hash map 1. Similarly, we're going to create another hash map called hash map 2. This hash map will have all the columns in it, all the column values, which are 0, 1, 2, 3, and initially all their values will be set to 0 as well. These are the keys, the column numbers are the keys, and the values as of now are 0 before we do anything. Now what we need to do is we need to iterate this entire matrix. Let's start iteration, and wherever we find a 1, that would mean what basically this indicates, if you think about it, what a 1 basically means here. This means that in this, whatever index that whatever R and C we reach at, whatever R and C we find a 1, let's say we are at here, right? We are at first row, second column. Let's talk about this. We are at first row, second column. What this value right here mean? Just focus on this server right here. What does this indicate? This server indicates that, all right, at the row 1 we have got a server, and at row and at column 2 we have got a server. That what this basically means. That's so far in our iteration we found a row 1, a row with like in the first row we found a server, so we increase the count in the first row with 1, and in the column 2 we found a server, so increase the count in column 2 by 1. So this I'm giving just an example. So we have to do the same thing for all the values wherever we find a 1. So let's do that. Let's kind of iterate this and see what we get with. So we are at 0, 0. We find a server at 0, 0. What this means is we found a server in the 0th column and we found a server in the 0th row. This is what it means. So we are going to have to update the count. So I'll say that, all right, we have found a server in the 0th row, increasing it by 1, and a server in the 0th column, so increasing it by 1. Let's move further. We come to this one. So what this means is we found a server in the 0th row and the first column. 0th row again gets increased by 1. Now this is a 2, and in the first column we found a server, so this becomes 1. Now let's come to this one right here. What this means? This means we found a server in the first row and the second column. First row value gets updated to 1, and the second column value also gets updated to 1, because we just found 1. Now let's come to this one. This is second row and second column. What does this mean? We found a server in the second row and in the second column, so you have to update those values. So far we see that alright, second row second row we increased 1, and in the second column we already had a 1, so this becomes 2 now. And yeah, this is 2 now, and then we come to the last part, and here we find a server in the third row and the third column. Third row gets increased by 1 and third column gets increased by 1. Now let's take a look at the hash map. What we are seeing, what are the final values? The final values are something like this. This hash map 1 which we created for the row indicates that in the 0th row there are 2 servers. Is this fact correct? It's correct. If you take a look at the 0th row, we have got 2 servers. Fine. In the first row we have got 1 server. Is this fact correct? It is. We have got one server in the first column. In the second column in the second row we have got 1 server. Is that true? Yes, it's true. If you see the second row we have got 1 server, and also in the third row it says we have got 1 server. Is that true? It is true. We have got 1 server in the third column. So this is how the hash map 1 tells us. Now let's take a look at the hash map 2. It says that in the 0th column we have got 1 server. Is that true? It is true. Just take a look at the 0th column. We have got 1 server. In the first row, in the first column we have got 1 server. Is that true? It is. So this is what the hash map says. In the second row we have got 2 servers. Fine. We have got 2 servers now. And in the third, this was also 1. In the third column, in the last column we have got 1 server, which is true. So now we have all the count for how many servers we have in each row and column. This is what basically it means. In each row and in each column, how many servers exist, we know that. Now how are we going to use these 2 hash map to get to the answer? Let's see. So if you take a look, right, for each server, no matter which index are we at, if we find a server, what is the minimum criteria that we discussed? The count doesn't matter. Really, the count doesn't matter. We can have all these entire column filled with servers, or this entire row filled with servers. If it has got at least 1 server to talk to, other than this, forget about this server. If it has got at least 1 server in this particular row and one server in this particular column in either ways, that would mean that this server has someone to talk to. We can have 100 servers here, 100 servers here, doesn't matter. If it has at least one server in this row, excluding this server that we are talking to, excluding this server, if there's any, even a single server on either side in the particular row, and any server on the either side on the particular column, that would mean that this server has someone to talk to. So what we mean by that is, if, and we already know how many servers are there in a particular row and on a particular column, we know using this hash map. So let's say I'm at this index, which is the first row and second column. If I know that in the first row the count of this number of servers is at least greater than 1, in the first row if the count of servers is at least greater than 1, that would mean that it has got at least someone to talk to in this particular row. So far we see that in this particular row, for this particular row the count is not greater than 1, it is just 1, because this is the only server in that particular row. But if you take a look at the column which this server is in, it is in the second column, and the second column we have got a count greater than 1, meaning excluding this server it has got at least someone to talk to. This is what it means. This is why we are doing a greater than 1, because we need to exclude this. You have to exclude this and this, then check it has got at least 1. So that is why it has to be greater than 1. Greater than 1, you getting my point? They could have been 100 servers here, but it needs at least 1 to talk to. So now our condition becomes for each RNC that now that we have these hash maps, this will help us to find if any particular server has got at least one server in its row or at least one server in the column to talk to. If that's the case, we'll include this server in our answer. So we found that this server right here has had no server to talk to in the first row, but had at least one server right here in the second column to talk to. We found this using this, the column hash map. It had 2 in it. So this is getting counted. Now let's take this example 3 cross 3. We are at index 3 comma 3. So in the third column and the third row, we see that the count is still 1. So it means that it has got no one other than its own to talk to. So that is why this the server got excluded. But in the case of the 0 comma 0, we see that in the 0th row it had 2 to talk to, meaning it had 2 servers in the 0th row, which means excluding this it has got at least 1. That is why the count the check is for greater than 1. The check is always for greater than 1. So this means that alright, it has got at least one server to talk to in its row. It doesn't matter if it doesn't have anyone to talk to in the column. If any one of the condition is met, it's fine. Either in its row or in its column, it's fine. So this is how the algorithm is basically working. Now let's try to quickly code this up and you'll understand better. So as we discussed, we need 2 hash map, one for row and one for column. Now initially the keys for the row, hash map will be the nothing but the rows indexes that we have 0, 1, 2, 3, 0, 1, 2, 3. So let's quickly do that. I need the row value, which is nothing but the length of this grid, and call value, which is length of grid 0. Let's prepare our hash map now. This step right here is preparing us this hash map. All values as 0, 1, 2, 3, going from all the way from 0 to the number of rows that we have, 0, 1, 2. It could have n rows, will go to n minus 1. All those values getting set to 0. The keys as the row and the value as 0 initially. Now we need to iterate this matrix entire RNC, and we need to update those counts, which we just did, right? Whenever we find a server which is 1 in a particular RNC, that count will get updated by 1. For that row and that column, that count will be updated by 1. In this case, we'll update the count of the first row and the second column by 1 wherever we find a 1. So let's iterate this matrix really quickly. This indicates we found a server. Gets updated by 1, and the column as well gets updated by 1. We have to store our answer somewhere. Store it here in this variable called answer. Now we have the hash map and the count ready. In which row how many servers we have, and in which column how many servers we have. This hash map has that value now. Now again we need to iterate to check that greater than 1 condition. Again we need to iterate this entire hash map, entire matrix for the greater than 1 condition we need to check now. If in that particular row, right, in that particular row the count is greater than 1, or in that particular column the count is greater than 1. If any of the condition is true, either in its row, either in its column, then we can say that already we found a server that has got at least any one to talk to, right? So basically this means that also we have to make sure that we are only checking this in a place where we do find the server. Right, only in this condition we have to make sure we check this. So what I'm trying to say is, the moment we find a server, we have to check that, well, right, if we found a server, in that row and that column did we found the case that we were looking for, that for, like, for that server, is the count in that row greater than 1 and that column greater than 1? In that case we'll just update the answer by 1, and then in the end we'll just return this. Let's try to run the test cases. So as you can see, it's passing all those test cases, and let's try to sum this now. Yeah, so it's beating all the test cases that they have provided, and it's taking, so this solution is pretty, it's not very bad, it's like, it's kind of good. Like you can see it beats 66.6, and we didn't use any BFS, it's just a simple hash map solution. So what I did so far is nothing complicated. All I did is coded up what we discussed so far, and this is the answer that we are returning in the end. And the time complexity for this is going to be m cross n, because at max we are only iterating the entire grid for m cross n. So that's what the complexity will be for this problem as well, m cross n or n cross n. Alright, that was it for today everyone. I'll see you in the next one. Like and subscribe this video. Bye.